Welcome. In this video, we will explore the concepts of transactions in DBMS, database management systems. Transactions are essential for ensuring the reliability and accuracy of data. Whether you are withdrawing money, booking a ticket, or placing an order online, transactions make sure that these operations are secure, consistent, and recoverable. What is a transaction? A transaction is a logical unit of work that consists of one or more operations. These operations access or modify the database. For example, transferring 500 rupees from account A to B involves two steps: debiting A and crediting B. If either steps fail, the entire transaction must fail. That is the core idea behind a transaction. Do it completely or don't do it at all. Transaction examples. Let's look at a few examples. First one, bank transfer. Transferring money must ensure both accounts are updated. Second, booking a ticket. If payment is not done but the seat is not reserved, it is a failure. Third one, online purchase. Updating stock and billing details together form a transaction. These examples show how transactions are used in everyday applications. Properties of transaction ACID. Every transaction must follow the ACID properties: atomicity, consistency, isolation, and durability. These four ensure that even in the presence of failure, the database remains accurate and secure. Let's understand each one in detail in the next slides. Atomicity means all operations in a transaction must be completed or no one at all. Think of it like a light switch. It's either on or off, never in between. If an error occurs halfway through, everything is rolled back. This guarantees data doesn't get partially updated. Consistency. Consistency ensures the database moves from one valid state to another. If a transaction violates a rule, for example, a balance going navigate, the transaction is rejected. This helps preserve business rules and integrity constraints. Isolation. Isolation ensures that the operations of one transaction does, don't affect the execution of another. For example, two people updating the same account should not interface with each other. This prevents conflicts, confusion, and ensure reliable outcomes. Durability. Durability means that once a transaction is committed, its results are saved permanently. Even if the system crashes afterward, the data is stored in non volatile memory or logs, so the databases can recover and remain consistent. States of a transaction. Every transaction moves through several states: active, currently executing, partially committed, last operation done, committed, completed successfully, failed, something went wrong, aborted, changes, rolled back. This life cycle helps in managing the flow of a transaction. Active state. In the active state, the transaction is executing its operations, reading, writing, or modifying data. It continues to be active until it either finishes or encounters a problem. Partially committed state. After the final operation is done, but before the changes are made permanent, the transaction is in the partially committed state. It is a brief period when the system is preparing to commit the transaction. Committed state. If everything goes right, the transaction enters the committed state. All changes are written to the database permanently. Now, even if the system fails, These changes will remain intact. Failed state. If something goes wrong, maybe a disk failure or power cut, the transaction moves to the failed state. It can no longer continue and the system must take action to maintain consistency. Aborted state. In the aborted state, the system undoes all changes made during the transaction. It is like pressing an undo button. The database returns it to its state before the transaction began. Transaction life cycle. The full transaction life cycle is start, active, partially, committed, committed or failed, end. This helps track the progress and handle failures at any stage safely. Transaction control commands. These are four main control commands. Begin to start a transaction, commit to save changes, rollback to undo changes, save point to mark a point within a transaction. These commands give you control over how and when changes are saved. Begin command. Begin marks the start of a transaction. Once you begin, all operations are grouped as one unit. No changes are permanent until you explicitly commit them. This lets you review or cancel the transaction later if needed. Commit command. Commit saves all changes made during the transaction permanently. It's like saying, I am done and happy with this. Once committed, you can't roll back the changes. They are part of the database now. Rollback command. If something goes wrong, you use rollback. This command undoes all the operations performed since the last commit. It is essential for error handling, especially in complex multi-step operations. Save point lets you set a milestone in your transaction. You can roll back to a save point instead of undoing the entire transaction. It gives more control and is useful in long or nested transactions. Nested transactions. In some cases, a transaction might contain sub-transactions. These are called nested transactions. If the inner one fails, only it is rolled back, not the outer transaction. This makes complex process more manageable and less error prone. Concurrent transactions. When multiple users run transactions at the same time, they are called concurrent transactions. This can cause issues like dirty reads, lost updates, or unrepeatable reads. DBMS uses techniques like locking and isolation levels to prevent such problems. Summary. To summarize, transactions are vital for maintaining database reliability. They follow ACID properties to ensure data is correct, isolated, and safe from system failures. Proper management of transaction states and commands like commit and rollback are key to success. Quiz recap. Let's test your understanding. What does atomicity ensure? Which command undoes changes? What state comes after partially committed? These concepts help you design better, more resilient systems. That's the power of transaction management.